welcome to Do the Practicals. So today we are going to discuss about how to implement 4x1 MUX using 2x1 MUX. So here is a block diagram of 2x1 MUX with two input D0 and D1, one select line S and one output Y. And also we have 4x1 MUX block diagram with select line S1 and S0, out inputs D0 to D3 and output as Y. So higher order MUX can be implemented using lower order MUX. So 4x1 MUX can be implemented using 2x1 MUX. So we'll see how we'll do this. And before that, if you had seen watched my last video, I had asked one quiz question in the end of the video for simplifying this logic circuit given. If you had solved this, that's great. Otherwise we are going to discuss this at the end of this video. So before that, we'll discuss our 4x1 MUX using 2x1 MUX. So see, 4x1 MUX. For 4x1 MUX we need 4 inputs D0, D1, D2 and D3, and for 2x1 MUX we need 2 inputs. So we'll use two 2x1 MUX with this inputs D0 and D1 for this input D2 and D3. So total 4 inputs. The output will be act as an input to this 2x1 MUX and final output Y. So though so the total, this will act as a 4x1 MUX, and in this blue line I had shown the select lines. So S0 is select line for these 2x1 MUX I had connected, and S1 is the select line for this 2x1 MUX. So total S0 and S1 will be select line for total 4x1 MUX. So you can see here we need 3 2x1 MUX to implement one 4x1 MUX. So this is the table of 2x1 MUX. When select line is 0, as you know, first input will be selected D0, and when select line is 1, second input D1 will be selected. Same here, D0 and D1 at 0 and 1, and at select line 0 D2 from here, and at select line 1 D3 from here will be selected as output. Same for this MUX. And this is 4x1 MUX table for combination 0 0 0 1 1 0 and 1 1. According to that, D0, D1, D2 and D3 will be selected. So how we can implement, we'll see here. So when S1 and S0 both are 0, then and both are 0. So when S is 0 for this both 2x1 MUX, first input D0 from here and D2 from here will be selected as output. So you can see here D0 is selected here and D2 is selected here. Now in this MUX S1 is 0, so first input D0 will be selected at output. So final output will be D0. So you can see that at 0 0 D0 is selected output. And now we will see for S1 is 0 and S0 is 1. So S0 is 1 and S1 is 0. So you can see that when S is 1, second input D1 from here and D3 from here at S0 is 1 for this MUX will be selected as output. So D1 here and D3 here, and here we know S1 is 0. So when select line is 0 for 2x1 MUX, first input is selected, so D1 will be selected. So the final output will be D1. The same will be for 1 0. When select line is 1 0, so S1 is 1 and S0 is 0. So S0 is 0 and S1 is 1. So here when S0 is 0, again for select line is 0 for 2x1 MUX, first input again D0 is selected, and here again D2 is selected, and here S1 is 1. So for 1 and 2x1 MUX have 1 as select line, so second input, So here D2 will be selected at output as D2. So output will be D2. Same for S1 is 1 and S0 is 1. When both select line are 1, so S0 is 1 and S1 is also 1. So S0 is 1. So 1 is, so when 2 cross 1 mux has 1 S select line, second input, so here D1 and here also D3. So again you can see D1 is selected and here D3 is selected, but as S1 is 1, so for 2 cross 1 mux when select line is 1, second input, so here second input is D3, so the whole output will be D3. So this is how it will act as a 4 cross 1 mux. So you can see that for 0 0 D0 0 1 D1 1 0 D2 and 1 1 D3 is selected. So this is how we can implement a 4 cross 1 mux using 2 cross 1 mux. Now this question which I asked in my last video as a quiz question for simplifying this logic circuit. So you can see here circuit with three inputs A, B and C. First NAND gate with input A, B, OR gate with A and C as input, and this C is given input as to second NAND gate with output of this first NAND gate and OR gate. So this whole circuit will make a Boolean expression as AB bar dot A plus C whole bar. So you can see here this NAND gate will produce AB bar with OR gate as AC, and this C will be input to, and this will make to this second NAND gate, they will be input to the second NAND gate, and the whole expression will be this one. And we have to solve and simplify this expression to make it a simple expression. So we can apply a De Morgan theorem. So by applying De Morgan theorem, this whole bar will be break with changing the sign, that is break the line and change the sign. So this line is broke to AB bar whole bar, A plus C bar, and the sign dot product is changed to plus sign. Now as you know, if an expression is having two bars above it, these they get cancelled. So this will get cancelled, this is cancelled over AB, A plus C plus C. So here also we can apply De Morgan theorem for this expression, A plus C whole bar, then break the line and change the sign. So again line is broke to A bar C bar, and plus sign is changed to dot product, and this bar we cancel, so it will be only AB. So AB plus A bar dot C bar plus C bar. And from this expression we can see that C bar is common, so we'll take C bar as common and A plus 1 plus A bar as in bracket. So any sum with 1 will give as 1. You can see here that 1 plus A bar is there, so with 1 we will add if any expression, if it is 0 then also it will be 1, if 1 plus 1 then also it will be 1. So no matter what A bar is, the overall expression answer of this expression will be 1. So we can reduce to AB plus C. So this will be the expression, the reduced expression AB plus C bar. So this expression will be the reduced one and will be enough to apply this logic, and we can prove this logic, prove these things by comparing the truth tables. So you can see the reduced circuit diagram of the logic, the reduced expression AB plus C bar. So only one AND gate and one OR gate with three inputs AB and C bar. So you will compare with the previous diagram, you can see that it was much more complex, but here it is reduced to just one AND gate and one OR gate. So AB plus C bar. So also we can verify this by giving input to verify for this expression and this expression. You will see at A0 0 0 the output will be 1. You can verify this. So for all these 8 combination, for 000 001 1 010 011 100 101 110 and 111, the output will be 1 0 1 0 1 0 1 1 for this expression, and also for this expression you can see 0 0 0. So AB is 0 0 0 plus C is 0 but bar, so it will be 1. And same you can see you can verify with all the combination, you will get the same input combination. You can see 1 1 0 0 and all are same. So in this way we can reduce it to a small circuit from a complex circuit. So in this way this can be done. So also there is one more quiz question for you. As we used 3 2 cross 1 mux to implement one 4 cross 1 mux, so this is a question that how many multiplexer can be used to implement 8 cross 1 mux using 2 cross 1 mux. So we'll discuss this answer in next video. If you know the answer, if you get the answer, you can mention it in comment sections below. Okay, thank you for watching. Please like, share and subscribe our channel, and thank you.